anyone go so far as to suggest that there is no associative evidence. This kid is just...
Well, I'm not saying that there's no associative evidence. I'm saying that there is conflicting data, which suggests that the associative evidence that suggests potentially a causal relationship between LDL and heart disease is not as substantial as people make it out to be. You
opposite land, where up is down, right is left, and Jason Blaha doesn't have Klinefelter syndrome.
Right, and where association equals causation, right? Oh, wait, no, that's in your reality, right? Your reality.
Plot the data from literally dozens of independent...
All right, let's look at this. Magnitude of exposure to lower LDL-C, millimoles per liter. You're right, this is from the consensus study, the consensus panel opinion. Right. Mendelian randomization. There you go. Okay, so not exposure. We're done. This wasn't measuring exposure, Haircafe. It was observing people that had a certain gene SNP that was involved in the production of LDL, completely neglecting to understand that the degree to which it will do such a thing is dependent on its expression in the physiological system in which it resides. It depends on their phenotypic expression, which is determined by their lifestyle. Not to mention that, once again, they weren't measuring exposure. They were observing the people and the proportion and reduction in risk. So no, the proportion of incidence of coronary heart disease. That's what they did. And you are forming an opinion based on this. The pros of this analysis is that it's a quite substantial sample size, 194,427 people, as compared to what a lot of other observational studies will be conducted on, like the one that was conducted by Nick Norwitz on 100 people that shouldn't have ever been done. N of 100. Good. Great. Median follow-up, 52 years. Okay, so it went on for 52 years. And then in these prospective cohort studies, it went for median follow-up 12 years. So median follow-up, by the way, you know why they used the median? It's because the distribution of the set of follow-ups in years was not normally distributed. It wasn't symmetrical. It was skewed. Good. Okay, fine, though. Median is supposed to hedge against any influence of outliers or any skew. That's why they used the median. But fine. Okay, so 12 years, median follow-up, 12 years of N of 400,501. Okay, great. And then randomized controlled trials, median follow-up, 5 years. Right. So we already covered randomized controlled trials. We already covered prospective cohort studies. There's the association doesn't equal causation aspect of it. There's the population aspect of it. The results of studies cannot be extrapolated to any other group not studied. Also, the degree of publication bias as well, and arbitrary selection criteria. So basically, epidemiological journals have the ability to basically report whatever studies they want to report by selecting the studies based on any criteria they like. So like men only, English only, etc. It's completely arbitrary in order to get the results they want published. And then there's publication bias. For example, most of the time when epidemiologic studies are published, it's only showing 3. It's only showing the amount of studies that actually showed a positive result in favor of the hypothesis that was put forth, which completely neglects to mention how many studies were conducted that showed a lack of a reinforcement of the initial hypothesis of the authors. They only show the ones that actually passed. So that's a problem. Then the reporting of relative outcome statistics as opposed to absolute outcome statistics, which is that's what I want to see here. What were, by the way, the R values here? This is a line of best fit. I'd like to see a confidence interval. I'd like to see a signal to noise ratio represented as a standard deviation with respect to the noise and not a standard error, because that's never appropriate to be using in this field, because a standard error refers to effectively the standard deviation of the population, which you can only actually responsibly report if you're taking a sample from a population that you know the full parameters of, by the way, which is when you actually start learning about the central limit theorem and how basically the sampling distribution of the sample mean of a population that you know the parameters of given that you have a sufficiently large sample size and or given that the actual population distribution is normal, approximately normal, will always be a normal distribution with the mean of it being the population mean. The standard error is the sample standard deviation in your samples that you conduct in that population divided by the square root of the sample size that is used in every sample. See, I actually understand this okay? So it better be reported with a standard deviation. And even then, it's associative. Why? That might sound desperate. I completely lend full credence to that argument. I understand. I lend full credence to the ability of that argument to be made with some reason behind it. Okay, it sounds desperate. It really does, and I understand that. It's one of the things I had to contend with. I thought to myself, that's got to be just due to inherent, innate desperation. That argument, but it isn't, and I'll explain why. You can have a perfect R squared value of 1 relationship between, let's say, even for example, LDL levels and heart disease incidence rate. And let's say that all of them invariably result in death. And so you might see an inverse association then, given that context, in a vacuum, with all confounding variables and spurious variables controlled for, of a lowering of LDL being directly commensurate with a reduction in heart disease presentation, let's say. Now imagine, though, that the way that they reduced the LDL was through statins. Well, then you cannot say that the reason for that direct 1-to-1 R squared value of 1 association, negative correlation, was due to the lowering of LDL. Why? Because statins actually happen to have chemically speaking, they have an anti-inflammatory effect. Well, so they didn't just reduce LDL, they also reduced inflammation on a chemical level. If there is a confounding variable that interferes with the result that you're actually studying, it has an effect on the other variables, even potentially, you must represent your results with ambiguity. Now, in this hypothetical scenario, you can make a far stronger case for LDL being causal in heart disease, in your opinion. This is where scientists come together. This is where they should come together, communicate with each other to form a consensus based on actual proper data. And even then, whenever they come to their conclusions, as a layperson, you have the responsibility to always doubt the authorities. Always at least have the ability to doubt them. Say, okay, interesting. I'll trust it for now because I'm worried with, I'm caught up with other things. I don't have time to actually look into science and how to actually conduct it. So these people know better than me. I'm going to put faith in them and I'm going to see what happens. Okay, that's why people still do that today. And I'm not saying that's a bad thing. What I'm saying is a bad thing is to never ever doubt them merely on the basis of them being in a position of authority. Especially when the redounding associative effects, by the way, we remain logically consistent here, of these axioms that they promote based on consensus continuously are negative. Then it must, that makes it incumbent upon other people to go, okay, maybe we must take matters into our own hands. This is how people run for office in the political sense. This is how people, things around me, they're not working. So clearly, they're not doing things right. These are the authorities. I'm supposed to trust them. This is how that works. But of course, you're chastised for questioning them in the first place. And that's the danger here. So I find myself repeating myself quite often, but that's what I often find myself doing in these videos.
Independently done studies on LDL cholesterol and cardiovascular risk, you get
not risk, also not LDL cholesterol. And you get what?
Incredibly strong correlations, as you can see.
No, that's your opinion. There are objective standards for strength of correlations, specifically with respect to Pearson's R and R squared values. R squared being, well, the square of Pearson's R, representing what's considered it's an explanatory variable. It purports to explain how much of your how much of the activity of your dependent variable is explained by the independent variable. But explained is a quite ambiguous term, which actually makes it a responsible term to use here, because people draw the false conclusion that necessarily means it's a coefficient of causality, which isn't true. And I just explained why that's not true. All right. I know R squared very well. Wow.
graph right here, or in this graph.
Okay, so let's look at this one. Weighted between group difference in achieved LDL-C level in millimoles per liter. Right, so I'm assuming this is going to be referring to a ratio, what they consider a lot of times a hazard ratio. They're going to be comparing intervention incidence versus a control incidence, right? And then they're going to aggregate that and compute that into a ratio. And that can be between 0 or over 1. 1 would be a complete equal amount of incidence in the intervention group and the control group. So anyway, okay. So relative risk reduction. So no, relative incidence, and it says reduction, which is another implicitly causal term, per 1 millimole per liter, 38.7 milligrams per deciliter, right? Okay. Reduction in LDL-C, 23% relative risk. So relative incidence, 0.77, right? So this is, 1 would be equal. They're saying 0.77, which means that there's a lower incidence rate in the intervention group compared to the control group in this population studied. 95% confidence interval. So that's looking basically at the distribution, and it's measuring how many different standard deviations away from the mean we're considering. It's 2 standard deviations away from the mean. You get 95% of your data around those points, basically. That's where 95% of your data lies. Within 3 standard deviations, that's 99.7%. Within 1, you've got 68%. So again, I'm just exemplifying that I actually understand what I'm looking at here. And of course, the 95% confidence interval, I'd wonder if they ran a bootstrap analysis to compute this, but 0.7 between 0.75 to 0.79, right? So it's right around there. It seems quite consistent in terms of the proportion. So, and then p-value of less than 0.001, which is supposed to indicate statistical significance. Okay, which also begs the question as to whether or not something is practically significant merely based on statistical significance being achieved, which is a fallacy, I'm telling you. So, relative risk of major vascular events. And then, yeah, 1 here. And then look, this is all weighted between group difference in achieved LDL-C level, 0.2, 0.4, 0.6, 0.8, 1.0. And it's just going up, right? And I'm assuming that the dotted lines are a confidence interval, but we already see that the confidence interval, there's not too much noise around that signal in this situation. Right, okay. Fibrates, 9 trials. So they basically aggregated a bunch of trials together. I'm assuming this is then a meta-analysis then. This is a meta-analysis. So it's actually, then you have to look at I would say that you have to look at the methods employed, but they're kind of giving that already. Statins, niacin, diet, fibrates, ezetimibe, yes, right. CETP inhibitors, 3 trials. Bile acid sequestrants, 2 trials. So all different methods, which begs an entirely different question. Okay, PCSK9 inhibitors, 2 trials. Right, okay. Now, but look at this here. This is a line here trying to connect these data points. This is a line of best fit that's calculated by taking the ordinary least squares regression analysis, basically. But look at these error bars around here. That's massive noise around this signal, because look at the sample size with respect to the amount of trials. 2, 4, 25. Notice how, since there's more, then it's got a lower noise around the signal, right? And what effect do statins have, at least initially? An anti-inflammatory effect, so you still cannot draw any causal relationships between LDL specifically and heart disease incidence, not risk. Niacin. Okay, so that's a B vitamin. Right, okay. Little noise here, little noise here, little noise here, little noise, more noise, way more noise, way more noise, more noise, and then PCSK9 inhibitors, one of the most commonly distributed drugs, massive signal to noise ratio here. Massive. Look at the error around this. And you're going to try and draw a line of best fit between these as if it means anything? Wow. Do you know how to interpret this data? So as the amount purports to go up, right, in weighted between group difference in achieved LDL-C level, right? So as the amount of the difference between the groups in LDL levels in millimoles per deciliter goes up, the relative risk of major vascular events, quote unquote, looks to be going up in studies that were conducted with completely different methods, with massive signal to noise ratios within the results of each study, with no confounding variables controlled for to any significant degree to even inform upon any opinion about, to make any opinion about this association being causal to any degree substantial. It's not going to be because of this. And I mean, again, not looking at risk, but incidence with a bunch of people that, once again, they're not controlled for. You're forming an opinion on this data. That's what you're doing. All of these interventions have multiple different effects. Even in isolation, these have different effects. And then you put a bunch of them together that have totally different methods, and then you say, oh, well, the reductionist variable that I'm going to attribute to be the actual causally related variable here is the LDL going down. Unbelievable. Seriously. Like in the dietary intervention, what else are these people, what else are the people doing and changing? What are they eating and what are they not eating? Healthy user bias and unhealthy user bias. The amount of biases that you've just compounded exponentially is absurd. And I say you, but it's not you. But you're lending credence to this type of science, and it's a damn shame.
Even look at the effects of lowering
Not effects, because that is the conjugate of cause.
cholesterol directly on the coronary arteries.
Oh my God. Wow. Another association. Okay, so y equals, okay, so this is basically the formula for the line of best fit. You can actually calculate this. You can do a rough calculation by solving for B and A. In this case, it's yeah. So y should really be the predicted value of y. It should be y hat on top, not y. All right. And so you've got a line of best fit here with no confidence interval here. So we have to question then what the signal to noise ratio is. It's LDL cholesterol milligrams per deciliter, not cholesterol, but a lipoprotein carrier for cholesterol, right? Okay. And then you see, what was the sample size, by the way? So O'Keefe, Jr., et al. The optimal LDL is 50 to 70 milligrams per deciliter. Optimal is your opinion. It's a value judgment statement. MLD decrease in millimeters per year. Right. Okay. P-value of 0.001. So that's supposed to represent statistical significance. And I'm assuming, this reversal AT, MASS. So this is another meta-analysis where it's basically plotting the signal for each interventional study here, or even maybe set of studies like we saw earlier, according to the, average LDL cholesterol level that was attained. Well, so also without any error bars around the data points themselves. That's another big problem. Okay, but cool, great. We understand what we're looking at, and we see a decrease 0.0, 0.01, 0.02. What is, by the way, MLD here? Let me get him to say it first. See, because as you see, there's a purported ostensible association. Well, there is an association here, but there's an ostensible causal association between the LDL cholesterol going up and a decrease in MLD, which is purported to be bad. Again, I don't know what it is, so let's hear what he says. He says direct effects on the arteries.
Cirrhosis occurs, and this is based on not just one study, but 14 separate studies.
So 14 separate studies. Yes, exactly. So N of 14 on this graph, by the way, which is going to heavily influence the R value and what the line of best fit looks like. We need to collect and really assess the signal-to-noise ratios of those individual study results. You're plotting the means of the studies of each study result on the graph without putting error bars around it. You've got to be able to do that. Now, I'm also hoping that the residuals here are normally distributed as well, because that's a way of looking at whether or not you missed something out of your data set or not. That was critical or important. R squared of 0.6116. Anyway, so an increase in LDL, MLD decrease. Again, what is MLD?
Since cardiovascular risk is directly related to
Not risk. Oh my God. Wow.
atherosclerosis, it's clear that lowering LDL cholesterol.
Oh my God. Wow. So another one with 1, 2, 3, 4, 5, 6 data points on the graph, on the scatter plot here. So LDL cholesterol going up, CHD events in percentage points. So you're being reductionist, basically. You want to talk about mechanistic speculation, and then here you go. Mechanistic speculation. R squared of 0.9305. Yeah, well, it's really easy to attain a value of that high of an R squared value if you have very minimal data points. Okay? again, with the formula to get the predicted value of y here, you can play, and that assumes that it is causal in the first place. It assumes that.
Lowers risk of atherosclerosis
Not risk, done.
disease, and this has all been demonstrated in multiple studies too.
Association is not necessarily equal to causation. I just gave the hard science way earlier. Yesterday, as I was sitting in front of you, exposing myself to offensive nonsense from you. Even then, okay? Atherosclerosis does not occur in veins. Unless you introduce the vein into a high-pressure area of the vascular system via a surgical bypass situation, by the way, which is very interesting. High-pressure area. Wow, okay. Well, that's very interesting, isn't it? Unbelievable. This is what happens when men try to play God. I mean, seriously, this is what happens. This is what happens whenever you don't perform science because you're a curious thinker that wants to just try and understand with humility the nature of the universe and try and get closer to approximating, some fundamental truths of the world, and instead want to construct your own stories about it. That's the result. This is the result that you get. A bunch of pseudo-sophistication. Because that's what this actually is. But anyway, despite the fact that they have the same cholesterol content, that's what I was saying, in both the arterial side and the venous side. And it doesn't occur as a blanket across the arterial wall either. It's in set sites.